Okay, 2.2 separable equations. So in chapter 2, we're talking about first order differential equations. So when you have the first order differential equation looks like this. When f does not depend on the y, then dy over dx equals to g of x, which can be solved by integration. Meaning when we have d over dx y equals to g of x, then take the integral for both sides. That means y equals integral of g of x. And then once you solve for this, we end up getting capital G of s plus c. But sometimes we have x terms and y terms, and those are the mixed up. So the first order differential equation of the form dy over dx times g of x and h of y. This means the x terms and this is the y terms set to be the separable, and we can separate these two. How? We can multiply both sides by dx, then we have dy equals g of x and h of y times d of x. Now I have dx on the right hand side with the g of x, but I don't like to have y terms with this x. So what I can do, I can divide everything by h of y. Then what's going to happen here is 1 over h of y dy equals to g of x dx. Now we can take the integral for both sides and find the solution. So the first example, dy over dx equals to x squared y fourth e to the 5x minus 3y. See whether this separable or not. So first thing we want to do, we want to multiply dx for both sides, right? So we have dy equals x squared y 4 e to the 5x. I'm going to separate this guy and e to the negative 3y times dx. And then on the right side, we don't want to have any y terms, so I'm going to divide all the y terms from the whole equation. Divide by y4 e to the negative 3y. Then 1 over y4, 1 over e to the negative 3y times dy equals x squared e to the 5x times dx. So it is separable because we have all the y terms on the left-hand side, all the x terms on the right-hand side. What about this guy? Again, we're going to divide or multiply dx for both sides. dy equals y plus cosine x and dx. That is y dx plus cosine x dx. I don't like to have y on the right hand side, so we're going to divide y. So 1 over y dy equals dx plus cosine x over y dx. So no matter what you do, you're going to end up getting y on the x term or x in the y term. So this problem, we have 1 in x coefficient. Instead of 1, I put the 2. So let's do it. I'm going to move this y term, y and dx to the right hand side. I have 1 plus 2x dy equals y dx, and divide y and also divide 1 plus 2x, then we end up getting 1 over y dy equals 1 over 1 plus 2x dx. So that's the first step. Rewrite the differential equation in the form of y terms together, x terms together. Once you do that, you're going to solve that differential equation by integrating both sides. So here, integrating in here. Then what's the integral 1 over y? That is ln absolute value of y equals 1 over 1 plus 2x, gonna be ln 1 plus 2x, and then plus c. Plus c can go either side, so it doesn't matter. When we differentiate this guy, then we're gonna have 1 over 1 plus 2x. And then since the x term has 2x, we have to differentiate this guy. So we end up getting 2 times 1 over 1 plus 2x because we need to multiply whatever the differentiate of that x term, right? So just like if you have a y equals to 2x, so you do the take the prime of y. It is, if you take the derivative of x is 1, however, we have this 2, so we need to multiply that. So therefore, when you have the coefficient in x or y, make sure you need to divide that number. This is going to be the common mistake you're going to have throughout this class in chapter 2 and chapter 3. So when we have the coefficient, make sure you divide the number when you take the integral of that. What's next? We need to take care of this ln. Throughout this class, your answer should not contain the ln. So I'm going to say that in problem. So make sure you need to simplify as much as possible, or I'm going to say, give me explicit solution. When I say explicit solution, you have to give me y equals to something. You have to isolate y on the left-hand side, y only. That's what we call explicit solution. There's another term called implicit solution, and implicit solution is just whatever you end up getting, just to leave it. So I'm not going to ask you specifically say implicit solution because you don't see explicit solution as the requirement, then you can just leave it. But if you see in the problem statement says find the explicit solution, you have to say y equals to something. So in the left-hand side is ln y, not y. So we need to make that to y. How? You take the e for both sides. Take the natural number e for both sides. Then we have e ln y equals e ln 1 plus 2x 1 over 2 times e to the c. Wow, wait a minute. What's going on in here? What happened to 1 over 2? And what happened to e to the c? E to the a plus b is e to the a times e to the b because their bases are the same. So the power we can just add or subtract. And then log functions a ln y is ln y to the power of a. You can take any number in front of ln, move it to power. Then e to the ln will cancel out. E to the ln, cancel that out. You're going to have y equals 1 plus 2x, 1 over 2 absolute value. And e to the c, e is the number, 2.7 something, and to the power of c, so we can just let that equal to another c. So I'm going to call it C1. I don't want you to use C again. Then if you do that, that implies e to the c equals to c, which is not true. So we need to introduce a new constant as a C1. Then y equals C1, and this is square root of 1 plus 2x. And inside of the square root has to be positive, right? And because of this absolute value, when you take that out, you're going to have plus minus C1 square root of 1 plus 2x. And then you can keep this absolute value there or not. It doesn't matter because inside of the square root has to be positive. Now we have a problem 2.2.4. Solve the differential equation by separation of variables. So we need to separate them as a step number 1. I'm going to move these x terms to the right hand side. dy equals y minus 1 squared dx. And then this is y terms. So we divide that 1 over y minus 1 squared dy equals dx. Now step number 2, we take the integral for both sides. If we do, we have y minus 1 negative 2 dy equals integral dx. That is 1 over negative 2 plus 1, y minus 1 negative 2 plus 1 equals x plus c.
So just like what we have integral y squared dy over, we have 1, this 2 plus 1, y 2 plus 1. So we end up getting 1 over 3 y cubed.
Then we have 1 over y minus 1 equals to x plus c. Is an implicit solution. And if I say find the explicit solution, then what you need to do, isolate y. So reciprocal of the left-hand side, and then we multiply -1 for both sides. We're gonna have 1 over x plus c and -1 right there. And then y equals 1 minus 1 over x plus c. Let's do one more. Step number 1, separate the terms. So we have a y here, e to the x. Well, I need to multiply dx. So dx is going to be right hand side, e to the x times y dy, and then e to the negative y plus e to the negative 2x times e to the negative y, everything times dx. And then we're going to divide everywhere by e to the x, y dy equals e to the negative x e to the negative y plus the negative 2x times e to the negative y dx. Let's factor out e to the negative y, e to the negative y, and then you multiply e to the negative x, then divide e to the negative y, or we multiply e to the positive y for both sides. Then we have e to dy times y dy equals e to the negative x plus e to the negative 3x dx. Now we separate them completely. Now we need to take the integral. Step number 2, integral y e to the y dy equals integral e to the negative x plus e to the negative 3x dx. The left hand side, we have two terms, so we need to do the integration by parts. I'm gonna let u equals to y, and then dv equals to e to the y, then v equals e to dy, and then du equals to dy. Now we multiply, then the left hand side uv, which is y e to the y minus integral v du e to the y dy equals integral e to the x plus e to the negative 3x dx. Y e to dy, take the integral of this, it's going to be e to dy equals integral e to the negative x, going to be negative e to the negative x. Integral e to the negative 3x, going to be 1 over negative 3 e to the negative 3x, and then plus c. Again, plus c could be left hand side or right hand side. I usually put the c at the end on the right hand side. Then y times e to the y minus e to the y plus e to the negative x plus 1 over 3 e to the negative 3x equals to c. Again, this is implicit solution. And then we want to find the explicit solution. Going to isolate y times e to the y and then move everything to the right hand side. And then y equals c e to the negative y plus e to the y e to the negative y minus e to the negative x e to the negative y minus 1 over 3 e to the negative 3x e to the negative y